Hello everyone. Let me just turn that down. Can you hear me a bit better? And then skip over that one because I'm not a huge fan of that one. I want to be alright. How are we? Are we all well? Welcome, Sertler, I believe, to the stream. I am indeed a nerd. Thank you for acknowledging me. Hello everyone else that happens to be here. There's been an exciting development in my streaming setup today. So I'm using pretty much the same setup as I was before, including the same computer and everything. So if you can hear a fan, soz. Talking of hearing things, can you hear everything okay? Welcome, Dale, to the stream. Hope you're doing okay. It was horrid, can't change it. Oh really? You can't change it? You should be able to. Well, maybe you can't. I don't know once you set a handle if you can change it or not. Can hear fine, cool. The exciting development is what we're doing today, but I have acquired on offer a pair of bone conduction headphones. So these are the ones I've got specifically. Outlier 3 Plus. I've got a pair of these things. Whoa, okay. Google, do you mind? There we go. I've got a pair of these things just in black. So now I can listen to the music that's on the stream and myself at the same time. How about that? I can be involved in everything. I could never deal with having headphones and then being able to listen to your own voice through the headphones. That, I don't know. That always kind of weirded me out. I was never a fan of that. And now I can be more involved. So that's a general update. Today, we are using this very fine service, CodeCrafters, to create SQLite from scratch in Python and figure out how this all works. I have not done one of these. I've only gotten as far as I have so far just to test that the thing. Well, not that it actually works, because I know it works, but I needed to set it up on this computer. So we've done that. And yeah, I have absolutely no... I have a little bit of an idea about file formats in general. I did create a very rudimentary file format once. Just like a zip style kind of thing. But I don't really know much about databases or anything, so we're going to be learning this together in apparently a theme that is appearing in streams of me covering things that I have no earthly idea about. You know, what could possibly go wrong? So for those that have never seen this service before, is essentially one of those services that allows you to learn programming languages and different concepts. So you can either, it's like if I were to do this in C, for example, or Rust, I'm not very proficient in those things, so I could set my knowledge to basic, and you could learn a new skill alongside a new language. Or, as I've done here, I've done it in Python, because it's a Python channel. I've set my skill level to, I think, advanced, or whatever the highest one is. And then you just learn the actual thing using a programming language you already know. So that's what we're doing. I might come back to this and do a language. I might try and do some Rust at some point on a stream, maybe. We'll see. But yeah, that is what we're going to be doing today. And again, I have absolutely no idea about any of this stuff. So if I'm rubbish, then sorry. Welcome. Oh, God. Zaxi to the stream. Hopefully I haven't butchered that. And I hope you're doing okay. So, take a quick swig of my water. And a quick clear of throat because I'm professional. So I've already got the environment set up in VS Code, including this main.py file, which is similar to the one we're seeing over here. All we need to do for this task is just to uncomment this code. This is what happens in the first task, and this allows us to print the page size. So I wonder actually if I should go through the introduction first. Yeah, there we go. Yeah, I'll go through all this first. just so we have a context of what's going on. So, welcome to the Build Your Own SQLite. I can't even say it. Oh, it is SQLite. Is it SQLite or SQL? No, it's SQLite, isn't it? Not SQLite. Have I been saying it wrong all this time? Oh my god. SQLite is a popular SQL database engine. In this challenge, you'll build your own version of SQLite that is capable of reading SQLite database. I said it again. Database files and answering basic SQL queries like select and using indexes. Along the way, you'll learn about how the SQLite. You'll learn about the SQLite file format, SQL syntax, and more. So I put Python as the language. I've put advanced as the proficiency. We'll see how that goes. Last time I did a Docker one. And I set the language proficiency to advanced, but this is seemingly like a master switch for everything. So it's sort of assumed you kind of knew what you were doing with regards to all the shell stuff you needed to do, which I didn't. I'm a newbie. I was well, not quite a newbie at Linux shell, but it just didn't give me any hints at all. So we'll have to see how that works out. The cadence, whatever, and accountability, whatever. Repository setup, it actually creates a GitHub repository for you, or at least a Git repository, and then you just clone it, and then you do it, and then you have it, and this is how it checks. So it actually monitors SQLite. Yeah, that's what I do as well, but it seems that it's SQLite. Yeah, it is SQLite. Wow, my life has changed. I've learned something new already today. Yeah, it keeps track of this repository for you, and this is how it works out whether you completed things or not. And it also has a test suite that it does automatically. It's quite nice. As you can see, it's not quite built for my for my Dart Reader extension, so the formatting freaks out a bit. But that's the case for most websites, to be honest. You just have to navigate all the things that are screwed up when you use this extension. So also, sorry for the flashbang. I've just seen it back on the monitor. So we're going to go in, I'm probably going to move this between monitors quite a lot because I'm going to need it in various different places. We just need to uncomment this bit. So this will get so we have the database file, if command equals .dbinfo, database file, which is, we pass it in as database file. And we have logs, and then we seek, or we skip the first 16 bytes of the header. We get the page size and we read 2. So that's doing, if we look at the SQL file format that it gives somewhere around here, is it in your task bit? Oh, it's in your task bit. So the actual task itself, in this stage you'll implement the dbinfo command, which prints metadata about an SQLite database. So we'll be able to run something like this, output metadata. Only needs to output the database page size, which is fine. SQL file begins with a database header, which looks something like this, and then there is an actual reference to it down here. And if we look at this reference, we can see how the file format actually works. So this has the header. Shouldn't you check the header first? Yeah, maybe. This isn't saying to do that right now. We probably could. Is there the header string? Oh, this is just a string. Yeah, we could check that. Why not? We can do some extra stuff. And then we have the database page size. Oh yeah, I was in here anyway. So yeah, the database page size is in bytes. It actually uses quite a clever system, is that it's 2 to the power of whatever's in here. Except that it uses the value 1 to represent 65,536, which is a bit strange. But sure, you'd think it would use 0 to do that, considering that 2 to the power of 0 is 1. Oh, right, yeah, 2 to the power of 0 is 1, and 2 to the power of 1 is 2, which it interprets as 65,000. It's a weird system. SQLite is weird. And then it has all sorts of stuff. So the file format version, file format read version, there's a lot of stuff in the header. File page cache size. Reserved for expansion must be 0. Yeah, there's always some stuff. The SQLite version. You'd think they'd just put the reserved for expansion stuff at the end. Although, how many flags are they realistically going to need? Is the answer to that. So currently, if we just run what we've got, it did say how I was going to run this. There's like a, there we go. Here's how you run your program. So you have your program.sh, sample.db, and then db.info. So if we go in there and then run that script, wow, okay, hello. So it'd be, is it here? Oh yeah, there we go. Your SQLite, oops. There we go. And then SQLite, oh, actually we'll do sample.db since it's already there. And .dbinfo. pipenv not found. Oh, goody. Didn't tell me about any of this. Virtual env, we'll do it about 3.12. Oh, what? Do I not have... Oh, I think I don't because I have Rye installed, but I don't actually like it. I did think about setting this up, and then I got... oh, and I want to do a full system upgrade, actually. No. I very much need to do one, but I don't want to do one right now. PyEnv, virtual env, 3.12, and then I guess CC SQLite will do. Oh, and then I've got it. That did not work. So this is the problem with PyEnv on Arch systems. I want a default one, yes. It's in the bloody AUR. Good. Yeah, I didn't do any of that setup. Or any of this setup. I am a professional. I finished setting up the stream and that with, what, like 10 minutes to go? I was like, oh, it's easy. I'm sorted. This is the easiest setup in the world. Meanwhile, I forgot to set up my entire development environment. Well, my computer's fans are going now. Yeah, I had on the previous stream I had Rye going. I decided very quickly I didn't like it. It's very opinionated on things it shouldn't really be opinionated about, in my opinion. Or like, not things it shouldn't be opinionated about, but it was opinionated against Python convention. Which, not too sold on that. Is it going to load? Python version. Is it not going to load that? No, it's not. What? Now I can't get the bloody thing to work. PyEnv local. Yeah, he's using that. Fine, I'll just activate it then. CC SQLite. Failed to activate. Oh, it's not been loaded in. That's because I've got to load it in here. And I'm going to do it up the top because I do not know what's in this file. So we're going to do PyEnv. It'll be eval PyEnv virtual env. Oh, God. I don't remember how to do this. You don't have to do this on Mac typically, and I normally use Mac for work and the such. There it is. So what the hell? Okay, that was weird. Yes, and then source it. There we go. We're in. So now if we do your... Okay, if we do like that. pipenv not found. I went to do brew then. It's nice that can I do pip install? No. Come on, I found pip. Because you have to do pyenv exec pip install pip env. There we go. I'm remembering how Linux works now. Now will it work? No, what? Where's it trying to find this? Exec pipenv. Can I do... I might have to edit it. There we go, I had to edit it. Pipenv found itself running within a virtual environment, so automatically use that environment instead of creating its own. The project, pipenv, sure, yeah, whatever. Is it going to do that every time? Yes. Is it pipenv verbosity -1? Why is it using pipenv anyway? That seems really strange. There we go. Okay, so we now have the database page size as 4096, which if we look, oh, we actually I forgot I have this. SQLite, oh, it now spells WoW databases. I did want to look at the raw file actually. I'm not sure how we would go about doing that. Show opened editors. No. I don't know. I also don't care. It's fine. Yeah, we have. So it's actually already populated with stuff, which is quite nice. So yeah, if we were to check the header as well, then we could. It would be, instead of doing, oh, what the hell? Instead of doing that, we could do read header equals, and then we can do that, and then we could just do, I guess, like assert header equals that, and if it isn't, if we change this like 2, we'll get an assertion error. Cool. So now we're checking the header as well. I use HXD. HXD? I've never heard of that one. HXD. Oh, it's a hex editor. Okay. Fair enough. We'll see if we actually need to delve back into the file. Oh, actually, you know what I probably could do? I probably could do. Would this do it? No. Yeah, I need to do some sort of hex editor. I don't know if I have one installed. Let's install one. Let's see if HXD is actually a thing we can use. Oh, it is. Okay. So I'm presuming HXD sample.db would just not work. Okay, fine. We'll leave that alone for now then, I think. What we can do now, there is a VS Code extension. Oh, okay. If you need to look at it again, I'll have another look at it. We might not need to delve into the file again. We'll see. Oh yeah, we have the command info. I did wonder how it was doing this, but it's just using argv. So now we can, if I do git ignore and then .python I don't know why I've done a star there. Python version. Because using pyenv, we don't want to track it. It's still not. Oh, because it's a hyphen, not a underscore. There we go. And then we want to, yeah, commit -am. What's the name of this step? Print, or just call this print page size. I think we can actually do like that. I forget what the command is. See, there's all sorts of stuff. There's a command that you can use to run some CodeCrafters stuff on the CLI, but I forget what it is. It might actually tell me. The tests have failed. Yeah, mark. Git push origin master. Have I? I haven't pushed it. That'll probably help. Oh, there we go. So it might say here, because this is all the remote stuff that it has. So it has like a fully engineered remote as well that tells you what's going on. It's just running the build. So it runs a build of everything and then it runs a test, and all this is kind of done for you, which is quite nice. I could just see the microphone idling. I got my computer fan and a desk fan running. So, soz if you can hear all that. Oh, what happened to step 22? course it's number 22. Birthday number, lucky number, all of it. That's just a bad omen. Things are going to go horribly wrong. Is it showing that the test... This is running... view instructions, what does that mean? Okay, I can't find... I'm going to see if... While that's going, I'm going to see if I can look up this like CodeCrafters CLI thing. Yeah, it has... I don't remember getting rid of that. The test command... How the bloody hell do you actually install the thing though? In the docs... Brew... Oh, I might have it on my Mac. Oh yeah, that'll be it. I have it on my Mac, not on this. So we can do... that. Okay, that's fine. God, that is still running. Oh, I keep... No. Install that. No such user... On... Do we not have... Oh, why is there a thing there? There we go, that was weird. Actually, let me check. Is it on the AUR? Before we do that. SY CodeCrafters. No. Is it anywhere on the AUR? No. Oh, that's a missed opportunity. I don't know if did the test pass? Oh, something bad happened. So now I believe I can just do that. Yeah, there you go. It's a turbo test run. It's expecting something it's not getting. PyEnv not. I wonder if it's freaking out. Oh, it's probably freaking out because it doesn't understand PyEnv. You know, I might. This is what I get for. This is what I get for trying to be fancy with it. Oh, there you go. They all passed now. Okay, fine. Git commit your. Remove PyEnv support. Sad face. No, not happy face. It's not. I'm not happy about it. Sad face. There you go. And now it should run just fine. Where's this? Oh, your tests. Your type in progress. Oh, the test passed. Cool. One stage is complete. Now we can move on to another one. So now read instructions. This stage you implement your own solution. Unlike stage 1, your repository doesn't contain commented code to pass at this stage. A whole 98% of people that took on this stage do it, so I'm going to be pretty embarrassed if I can't do this. Your task below contains a description of what you need to implement the tasks. You also have the code examples. Oh, hello. There's a lot of comments and stuff down there as well. Let's not get spoilers. Well, this is immediately a hard one. We'd expect a proficient developer to take more than 1 hour to complete this stage. What? I didn't say that before. Hang on a second. I could have sworn on my life it did not say that before. Log in. Build my own. Where is it? One of these. Oh, that one up here. No, okay. I can't actually show it because I've already started it. I remember this not being hard though. Cool. I'm gonna be apparently gonna be here. I've only got 2 hours in the bloody stream. I'm gonna be here for about half the rest of it. Fine. Number of tables 2. Okay. Yeah, I've read the thing. And implement your solution. It just tells you. Yeah, just implement it. I guess we go into the header and figure it out. Oh boy. In last stage we saw that a dbinfo command prints this in the output format. We implemented database page size on the last. Focus on another value, the number of tables. To find the number of tables we need to count the number of rows in the SQLite schema table. Okay. Okay. Oh, do we actually need... Right, okay. Yeah, it does just kind of like leave you on your own a bit sometimes. It just goes, yeah, look at that, we'll be fine. Okay, so page 1 of the database file is the root of the table. The root page of the table B tree that holds a special table named SQLite schema. This B tree is known as schema table. Does it say how big it is? SQLite table contains one row for each table, index, view, and trigger collectively objects in the database schema, except there is no entry for the SQLite schema table itself. For internal... oh lord. Oh lordy lord, what have I got myself into? Alright, well let's get that hex editor, shall we? Hex editor. Let's see what we've got. So we're probably going to need it. Ghex. Okay, let's try Ghex. Oh, I don't want a terminal. I just want to go back into this code. Parado dash sy ghex. Yes. Oh, it's an extra. Ghex. Oh, hello. There's a graphical one, that's nice. Ghex sample.db. Okay, so we have our SQLite format, and then we need to... Oh, this is the one I had before last time I was trying to use this, and I couldn't figure out how it worked. That's good. So we need to do the offset. We go back in here and have a look at... So the database file format, how big is the header? Exactly 100 bytes. That's convenient. Okay. How many bytes are on? I don't... Is there like a... Just like 100? Nope. Oh, now I'm editing stuff. Oh, I don't want to do that. Oh, what? How do I go? Is there a go to? Jump to byte 100. Okay, so there's 0D here. And then there's an awful lot of zeros. So I'm guessing this bit here is the bit we care about? I also don't know where the pages actually are. Let's see what the comments say. Because the comments had a good amount to say about this. First page of the database, after the database contains a leaf tree, B tree page. Each cell has a payload that contains a record. The body of each record corresponds to a row. Since SQLite schema table stores information about tables in a database, number of cells. This leaf table B tree page will give us a number of tables in the database. You can determine the number of cells reading B tree page header. Let's have a look at this. I have binders full of sandwiches. Isn't that the most relatable sentence I've ever read? I'll show sandwich data exists as an array. We use record format for inserted data. We can see the following bytes on the disk. Let's break this down. The first byte of 0x15 is the size of the row's payload in bytes. Okay, so if we so we're reading 18. Right, so check the header is correct, sure. Get page size, and then get number of tables. There's not enough video to maintain such. Oh, really? YouTube's doing something weird. If you're experiencing lag spikes right now, do apologise. I'm just getting an error. OBS looks happy. Oh, it dropped 346 frames. It doesn't seem to be dropping anything more, so I think we're alright. Okay, number of tables. So we need to get past the rest of the header. So I think we can just do database file dot is seek like the total offset. I don't know if seek's the offset from the start of the file. Okay. Offset whence. I do like the whence argument. Python seek input and output. It does. Okay, that's fine. Cool. I've never really used seek much. Whenever I've had files, I always just use read to skip on as many things as I need. Okay, so seek 200. Oh yeah, because if you do seek 0, it goes to the start, doesn't it? Yeah, of course. So seek 100. Number of tables. No, it's not going to be quite that easy, but it's going to be the record size equals, and then it'll be dot read. I think 2. This is already much more helpful than the SQLite documentation. So the first byte. Oh, it's the first byte, so it's actually just the 1 byte we want. Ooh, hello. There we go. It's the size of our row's payload in bytes. After this is our row ID, which is used as a primary key. Since this is the first ID, it has a value of 1. Okay. Wait, what's this? Hang on, I don't think is this right? Oh no, because the first one. Hang on, I've already lost myself. I tried to remember sandwich out last week. Have a record. Okay, I think that's just. Alright. I think we're alright there. I was just getting confused because I realised it wasn't talking about the start of the file. If we do. Get rid of that. And then we want. I don't know how to actually write a new test for this. Do we just. Oh, we could just do a cert. Record size equals 100, and we'll see what it comes. No, yeah, we could just print the record size. And that's fine. Although we can't just run this. So if we go back in here and do pyenv exec, saying out return to the print. I think I made a typo or something. Do you mean like the autocorrect like this, or like this, or that? Because the former is VS Code, the latter is something called Codium. So your battery low. Oh, my headphones are running out of battery. That's good. They might die. Yes. Well, yeah. Sample and then thingy, whatever it's called, dbinfo. 13 is the record. So this said that the each cell has a payload that contains a record. The body of each record corresponds to a row. Okay, that's fine. So we now have the size of our record. So the record equals int dot from bytes. Yes. So we now print this record. It will look like that, which might not actually be that helpful. We probably don't want that actually. We probably just want because we don't want the size. We just want the actual record. So we can just do that. I don't like the look of this. I don't like the look at this null byte. Oh, shut up. This is really having a go at me now. First byte of naught is 15 is 0. It's just a primary key. First two fields are what's called a variable length integer encoding. Oh, my headphones are now shouting at me to charge them as well. This encoding is used so that we don't have a huge 8-byte field for every integer and a waste of bunch of space. Like a sandwich shop, packaged every sandwich in almost 6 bytes of containers. Variance uses a simple trick. The high bit is used as a flag to indicate if there are more bytes to be read. The 7 bits are our actual data. If we want to represent 1,000, so a binary representation is split into separate chunks. Oh my god. Oh my lord. Okay, I don't think use a primary key. Oh, the first two fields use what's known as a variable length integer. I don't like the fact this is a 0 byte. I feel like this might be a bit wrong. Can I find this table? It's not SQLite sequence, is it? No, I don't think that table can actually show that. Then we add on flags at the beginning. Yeah, whatever. The type encoding was okay, weird. You have a list of column types, name, size, count fields. Each data type is a different encoding that's specified as a variant. For our name column value 0x1b, so we have 1b here, which is the name column. Where did you get that 100 seek from? From the size of the header. So we want to skip the header entirely. So we get to the first page, I guess. That's how I'm seeing it anyway. Yeah, after the database header contains a leaf table B tree page. Number of cells in this leaf B. Reading B. Oh, hang on. The number of cells will give us the number of tables in this database. Oh, this might actually have a simple way of doing it. Oh my god! The 8 or 12... A V-tree page is divided into regions in the following order. The 100-byte database found on page 1 only. Okay, so yeah, we are on page 1 currently. The 8 or 12-byte B-tree page header. Oh, so the B-tree... These headphones are getting more and more angry at me now. A 2-byte offset 3 gives the number of cells on the page. So it should be this, right? Just that. We don't have to do any of this. Why did it give us the other hint then? That's really weird. So if we get rid of that for a second, and then the 8 or 12 byte. Why is it 8 or 12? The 1 byte flag at offset 0 indicating the B tree page type. So if we just read, okay, page header database.file read, and then the next 12 bytes, and then we just print. I don't know how we figure out whether it's an 8 or 12 byte one. There's a /r. There's a bloody carriage return in it. Okay. A value of... what is R in... Wait, what the hell is a carriage return in a... I forget, is this way around? Oh my god, I cannot type. There we go, bloody hell. So 49, and then so we need the order of a carriage return, which is 13. Ah! That was a value. A value of 13 means the page itself is a leaf table B tree. page. Okay, that's fine. So the page type equals page header 0. Sure. And then the 2-byte integer gives the start of the first free block of the page with 0 if there are no free blocks. So we could just skip over that. And then we need to read another 2. Database file.read 2. And then number of tables equals database file.read 3. How big is that? That is another 2. No, I need read 2. And then I need to int.from bytes equals that, and it should print. I don't know what format it wants it in. I guess that. We'll give that a shot. So if we then print that, number of tables equals 0. That's not correct. That's true. I don't need to be reading more. The number of tables is the page header 3. So offset of 3, and it's another 2, so 3 through 5. And then int dot from bytes. I get the sense that's not really the way around. Number of tables 3. That looks better. Yeah, there's 3 tables. If we would, I don't know if we can add. If we go, do we have SQLite 3 on here? We do. Open sample db. Oops, that's not what I wanted to do. Open sample. Oh, there go my headphones. That's good, isn't it? Oh, what is? Oh, there's just no music. Okay, that's fine. Well, I can't hear the music anymore. That's good. So if we do, I guess, sample2.db, and then we create table test. Can I just do that? No, it needs stuff. Okay, that's fine. So long as you can still hear me and you can still hear the music, that's fine. I can't even remember how the bloody create table syntax works now. If not exists, table name. It should just be like test int, I guess, like that. There we go. Dot tables test. Sure, that's fine. And then if we load, oh hello. If we load this against sample 2, this should now be number of tables 1. We've done it. We've done the thing. We don't need the page type then. So we've read the page header. Sure, okay, that's fine. Number of tables, and now we do our CodeCrafters test and hope everything works. Although it's probably going to break because I've put pyenv back in here. Number table 6? Excuse me? Where have they got 6 from? Oh no, we've passed. Okay, it must have been some other table. Oh, it's using some other database. I still don't quite know where it got 6 from because number of tables 2, number of tables 1. Where did it get 6? Okay, that was weird. I don't know. We've done it. Oh yeah, you can do CodeCrafters submit, can't you? And that will, whoops, that will send everything up. Okay, that took less than an hour, mainly because other people had gone before us. Cool, they've passed. Let me look at some of the examples and see what other people have done. Ah, boo! They've used... oh, hang on. No, that's not using the thing. hell? Skip the first 16 bytes of the header. Page size, number of tables, line count, create table for line in database file. That seems like a really cheap way of doing that. Wasn't there one down here? Don't be fooled by using the cell count for the header of the first page. It happens to be identical to the sample database, but the two are only correlated. So I think all these ones have actually not done it right. This is just using SQL parse. I feel like a lot of this is just cheating. We've done it the proper way. As in the way that random guy in the comments section told us to do it. Oh, this person's done it properly. They've done a bit more validation. Maybe we should do that. All right. 0 to, yeah, that'll be 13. Yeah, we'll add that in actually. That's probably good to do. So if page header 0 does not equal, how the hell do I do? How have they done this? Oh yeah, they've just used that syntax. That's cool. Raise exception invalid. Sure, whatever, that'll do. Indexing on bytes, returning it in. Oh really? I did not know that. That sounds like a very good community polls question. That sounds like I could screw a lot of people over with that one. I'm going to make a note of that. That's a good fact. Slicing by, or not slicing, indexing bytes returns. There we go. There you go. Cool. So now we've done that, we can do CodeCrafters submit again, and that'll probably still work. Cool. I think now we can go back to the instruction. Mark stage is complete. We can move on to the next one. Print table names. Oh dear. Number of tables. Here's the output it expects. Oh no, it hasn't moved on yet. Now we want to create a whole new command. Okay, so first we're gonna want to create a elif command. Whoopsie daisies, equals dot tables. We need to open the file again, and then I have no idea where all this stuff is. I don't think, should we like move the open? No, I guess if it's not a valid file, we wouldn't want to open the file. It seems a bit weird. I feel like you'd want to check this header every time. I guess we don't really need to worry about that right now. So if we so get table name, not tables names, and then we skip to database dot seek or database file dot seek 100. Then we have the page header. I don't know if it would be in the page header still. I'm really not sure it would be. So there isn't really much in the way of talking about the header in here. This is the header here. Does this have the names in it at all? I doubt it would do. A 2-byte integer of the start of the cell content area. No. Okay, what ingenuity have people come up with here? Understand documentation of MySQL. Hexed. You binary view the content of the DB file and reference it with the documentation. Okay. The first page includes the database header. The first page is considered from 0 bytes to page size bytes of file. Cell pointer array contains offsets with reference to the 0th position of the file and not the 100th. I don't understand what that means. So there's nothing in the comments for it. We could go and look at the code examples if we get really stuck. We're going to try and not do that for now. So we have the page header. We might as well read that. I wonder if I could just cheat and get the error to do it. Could you imagine? Oh God. So the database internals. Is this going to have the table name? Oh, actually, this did, didn't it? Type encoding. A list of column types. So that's column types. We want the column names. It's not. It can't be that much, can there? Surely. This person used. Let's try this. Actually, let's go back into ghex and see if we can figure out. Is there anything in? There's just nothing here. Oh, here we go. Oh God, why did I do that? There's no like scroll bar or anything, which is good. So that is the. Oh, we want like. Can we just search for Apple? It's got to be just in here as text, right? Surely. No, that is finding. That's trying to find bytes. Oh, I can do apples. There we go. No occurrences found from the cursor. For real? Oh, I do not understand how this input system works. Oh, there we go. So it's in here twice. What the hell? Table apples. A bit strange, isn't it? So this is, oh bloody, God knows how many bytes in. So gtable oranges. I wonder if we just need to look for, oh no, nine table oranges. Apple. Oh. I don't know how many bytes were in. Oh, it actually has how many bytes are in off it. There were bloody miles in. So this is 21. Can I get like a reasonable amount? 20. There we go. This is now getting 20 bytes at a time. EC0 is or no character. Oh, int on from. But no, what the hell am I doing? 0xEC0 3776. That seems odd. That seems really odd. Why the hell is it? That can't be right. No, it's saying it's starting from like, yeah. That's weird. Oh, it's because it's not 20. It's not 20 bytes. It's 20 bytes in hex. Yeah. I'm thinking there's got to be something that takes us all the way down here. I was just trying to figure out where in the file it was, and it's quite a way in. Which does not really help. Well, let's see what this print page header. Can I just move this? I don't want to. How do I decouple this? Unsplit the terminal. There we go. I've got to put pyenv back in this stupid thing. And we do your SQLite 3. Do we not print anything? Oh, yeah, because we need dot tables, and we also need the original thing. So that's the header, supposedly. All other B tree do not omit this, so we want that first one. This reserve region is an area of unused space at the end of every page. Extension is used to hold per page information at the end of every page. Size of this reserve region is determined by a 1 byte unsigned integer found at an offset of 20 in the database file header. The size of the reserve region is usually 0. So if you go back here, so this is the main offset 20 bytes of unreserved space, unused reserves, usually 0. Does that? Oh, okay. Oh, the cell content area. Ah, it must be the cell content area because all this. So that's all 0. If this is all 0, the unallocated space is that huge block of 0 we must have seen. The cell content area must be stored here. Designates the start of the cell content area. It's a 2 byte integer. So if we get print, so start, oh god, cell content area start, I guess, will be explicit, why not? Equals int.from bytes 5 through, oh, I actually knew what I wanted to do. That was, I have a feeling my AI knows more than I do. If we then print cell content area start, whoa. A long way in. Something like, what is that? 247 million bytes into the file. That isn't the page size only something like 4096? God. Here we go. Cell pointer array of B tree pages immediately follows the B tree page header. Let K be the number of cells on the B tree. Oh, this cell pointer array. Maybe that's what we want. And in key order with the leftmost cell first and the rightmost cell. The cell content region of the B tree page. It's where to find the name. Yeah. That's what I'm trying to find. You read 3 bytes, not 2 bytes. Oh, did I? Whoopsies. Oh, maybe the AI doesn't know what it's doing. 967 still seems. No, I think I read like 4 bytes. Oh, there we go. So bytes 5 and 6. Okay, cool. Yeah, so that was right. 3,779. Down here, I think we got 3,678. So we start here. This here is byte 3,779. So the first 2 bytes are empty, weirdly, and then you get to this byte, which is just an X, and then you move forward a bit. God knows what these do. Okay. 3 blocks. What's it talking about? Welcome, Panning Box to the stream. Hope you're doing okay. Thanks for all the hearts, whoever's giving those as well. can just see them fly off. I've got my control panel on my Mac. Free blocks, no. Cell content. Here we go. Header. All right, let's have a look at these and then see what we can work out. None of those match. I'm even looking at the right bit. Oh, what is this? Hang on. So it's the cell content area. Designates the start of the cell content area. So points where a cell content is stored in the cell content region of the B tree page. SQLite is unallocated region. If a page contains no cells, it is only possible for a root page of a table that contains no rows. The offset of the cell equals to the page size minus the number of bytes of reserved space. Okay. Free block is a structure used to identify unallocated space in a B tree table. We don't need that. Time out free space. The variable length integer is a static Huffman encoding of 64 bits. Variance between 1 and 9 bytes. No, so the format of the cell. It's a B tree leaf cell. It's supposedly supposed to be one of those. So 0D, 05, 0A, or 02. Interesting series of indexes. That does not appear to be in this region here. There's an X. I don't know what that means. I just need the column name. That's all I need. Spills out. It depends on the page type. God. Here's an alternative description of the same computation. Bloody hell. So, tell you what, someone put a lot of effort into this. someone really put a lot of effort in. So I guess, so there's this is 47 here. There's this series of bytes here, 74 through 65, which indicate the start of a table. I don't know if we should really be looking for those. There's got to be some sort of pointer somewhere. So B trees are meant to be fast. Yeah. Very true. Well, fast to use, maybe not fast to figure out how they work. Seemingly. So we've got a table there. How do we find out where that starts? Because I very much doubt it would require us to seek until we find the text table to do that. And I really would rather not do that. So there is an X there, and then there's a G. I don't know what the significance of this G, and then this is Y down here. I know they're not supposed to be like that. Create table, SQLite sequence. Create table, apples. There just doesn't seem to be any pattern. There doesn't seem to be any sort of indication. Yeah, they are. But I'm sort of wondering, because they're the character before a table, and I'm wondering what their significance is. They're probably some sort of length character. So this G here would represent that is hex 47, whether that might be characters in the table definition. And the Y down there would be, there's X 0x59, which makes sense because it's a longer table now. And there's 9, I guess. 39, hex 39. Yeah, that makes an amount of sense. Yeah, okay, so that's the length of the tables. So what is this X representing? And why are there 2 null bytes at the start of the thing? I really don't know. I don't know what those 2 null bytes are. Cell content. See, it doesn't really talk about the cell content area at all. Does this talk about it? Cell content. No, it doesn't. Good. Well, it makes you think about it, doesn't it? As far as I could tell, this sort of a struggle is like the entire idea about this. That it's supposed to make you think and it's supposed to make you work all this out yourself. With just a few hints. Area SQLite. Blocks of contiguous requirements. So, oh, what is this? So, okay. H3850. I don't know what that means. 2 byte big endian integer start at byte offset 5 of tree contains the byte offset from the start of the page to the end of the cell. Hang on. Contains the byte offset from the start of the page. Oh, yeah. Seems all space from this offset to the end of the usable region of the page. On page 1, this field is stored at offset 105. All B tree cells on the page are stored within the cell content area. Is there like table name or something? No. Oh, this page has no title. That's good. Let's have a look at this. Yeah, we're not going to get anywhere near as far as I thought. I mean, we've got like 52. We've done an hour and we've not got very far. So the database header, the root page. Okay, the root page is used to store information about the tables contained within the SQLite database. This is in itself a table, albeit a hidden one. Okay. Table has a number of names, but the documentation refers to SQLite. Also has different names. SQLite B tree. All data stored within a B tree in SQLite database. Decoding the SQLite schema table. I think this is the bit we just read. Yeah. The 2 byte integer offset 1. The cells on page 2 designates the start of the cell content area. 0 value for this is represented as cell. Does it talk about the cell content area? Oh, that's all that stuff. Okay, fine. Sequence area is. Let me zoom in a bit so it's easy to read for everyone. So each cell offset we're expecting a 4 byte big endian integer that is the page number, left child, and a single variant immediately after. That's about what this one down here. It's a little bit. Oh god, they're all a little bit low res, aren't they? If you get to the beginning of the page, you find the date for that record. Even the page header on the page starts at offset 100 due to the database header cell offset. Now we know that into the table we get what? Hang on. Let me read this bit properly. As we can see from my earlier template, there's a table interior page. Page type is 0x05. Is it? Let me figure that out. So each cell offset, we're expecting a 4-byte big endian integer. There's the page number of the left child and a single variant immediately after. If we got to the offset for cell pointer 1, 1019, I don't know how we got there. From the beginning of the page, we will find the data for that record. Note that even though the page header on this page starts with offset 100, due to database header, the cell offset starts from offset 0 of the page, which is the start of the database header. Cool, that makes no sense to me whatsoever. If we interpret it as a 4-byte, we get 0x0006, value 6, and the variant is a single byte variant or variant with a value of 3. Repeat the step for all offsets of data. Oh, Jesus Christ. I have no idea what this is trying to say. What bloody editor is that? I want that one. That looks quite useful. Note how each page relates to a set of key values. Have a look at earlier query. We do not see any key values. Primary key is not defined. Each record gives. That's a record. Oh no, these are records. It's not what we want. Table name. Nothing. Oh, maybe because I can't spell. Table name. Nothing gives us the bleeding table names. They're both file format. Table name. Oh, here we go. SQLite schema. That's the only time that's referenced. Yikes. How do we get to the... Alright, I'm looking at the code examples. I need hints. We don't have all the time in the world to figure this out. So let's have a look at what people have done. Yeah, show me the code. So they do it. Page header. I do some crazy stuff. The cell pointer array. Oh, they go into the cell pointer array. Oh, we're in the wrong bloody bit, I think. Are we? Cell... Hang on. God, I'm looking at the bloody code and I still don't fully understand it. The page header, password, okay, sure. Database file at seek, 100 plus 8, skip the database header and B tree header. I hate it when people do comments like this. Like, they stick it on the end of a file and then black formats in a stupid way. Put the comment above the line. If it's a long comment, jeez, it's not difficult. Just having a go at someone. Cell pointers. There are a lot of people who work that do that. It really pisses me off. Cell pointers. So that has all the cell pointers. Database file seek cell pointer. Number of bytes in payload. I think we've been looking at the wrong bit this whole time, which is good. Right, well, let's go back to the cell pointers then and use that instead. So cell pointer array gives the number of cells on a page. No, that's not what we want. Start the cell content area. The number of cells on a page. No, but there's no pointer for that. Within the header of interior B-tree pages only is omitted from all other pages. Immediately follow. Oh, the cell pointer array immediately follows the header. Okay. So we actually need. Okay, if I bring this over on this screen for a second. So to get to the cell pointer arrays, we need to. Well, we first need to figure out the page type. Which means we've actually done this up here wrong, but shh. Don't worry about that. So the B so the page type is that if the page type is the interior B tree pages only. So if it's 02, if page type, don't know why I want to do that, equals 0x02. Oh, we want it to be in 0x02 or 0x05, then we want to the page header equals database.file.read and then another 7. Otherwise, else we want to read 11, because the one down here is only available for the interior B tree page, and this is probably a leaf B tree, so it's not going to have that. So what we actually did up here is we read it into the page cell thingy. But it's fine, it's all right. It doesn't matter. So the page header, it looks really ugly. This code is horrifically ugly at the moment, but just make it work first. The B tree page, let K be the number of cells on a B tree. A cell pointer consists of K 2-byte integer object. Oh, okay, we need to find the thingy then. So yeah, the page. We have the page header. The number of cells on the page equals int.from bytes, and then we need to do 3. So offset of. There's not an offset of 3 anymore, is it? Whatever. I'm actually just gonna read it like this. So the first free block. So free block equals database dot read, and then that reads 2. And then we have the cell content area. Yeah, the number of cells on a page equals int.from bytes, and then we want to read another 2. And then we can do, so we've done 1 to 5. We then do cell content area equals database file read another 2. Number fragmented is another 1, and then if page type is in, we want to do int.from bytes, whoopsies, byte order equals big. So if the page type is in 0x02, 0x05, and I should really do it in sets, then we want to the rightmost pointer equals, and we don't really need that. We could just read another 4. Who cares about that pointer? Okay, so that's actually reading all the things in. So now we have the number of cells. Oopsie daisies. So it says here the cell pointer array of the B tree page immediately follows the B tree. Yeah. Let K be the number of cells on the B tree. which is we get from here. The cell pointer array consists of k 2-byte integer offsets to cell contents. Cell content. The cell pointers are arranged in key order. The leftmost cell with the smallest key. Okay, first, and the rightmost cell last. So we need two cell pointers. Yeah, database, and then we can probably split this. It's a byte string, we can probably do that. No, actually we don't want to do that. We can't split it. We can do for I in range number of cells. Maybe. Yeah, we can do that. So number of actually, let me print the number of cells first. 3. Okay. We need to get. So we need to do the name, the key, and then the value equals database dot read to, and if we print key value, 15143, 1561, and then 14195. What the hell does that do? Strives to place cells. Is that what we need? Is that where we need to go? What has this code done here? For cell pointer and cell pointers. Okay, this has done the same. It's just create a list manually. For cell database.seek cell pointer. Okay, we just seek it. That's a list though. What? So in.from bytes, and I'll bring the code on the screen. In.from bytes, database file.read 2. Big. And then it just uses that whole thing? And what about this whole key value thing that was going on about? K2 byte integer offsets, the cell arranged in key order. Oh right, I misunderstood the documentation. So yeah, I've screwed that up colossally. So pointer equals that, and then we can print the pointer, and then we actually want int.from bytes byte order. I don't know if this does anything. It just kind of decided we were going to do this one day. That is definitely going the wrong way around. Smallest key first, and the rightmost cell with the largest key last. That's not what's happened at all. We got the last one first. Is this not supposed to be this? Is this wrong? No, that changes nothing. What? How the bloody hell has that happened? Fine. It's alright. That's really strange, but okay. We'll just continue on, I guess. Oh, this guy's got a parse varint function. Jeez. Number of bytes in payload. At this point, I am not sure. Okay, let's go back into our hex editor and see. So we go to jump to byte 3983. Yeah. Just jump to. Oh, it's actually, yeah, it's taking us back to 3779 again. So we jump to byte 3779 is way up there. Is it? Oh, no, it's not. 3779 is that X. Now we're back in exactly the same position. For God's sake. Oh. Well, at least we have a series of pointers. Figure it out. So that must be the size of the information. So if we were to read the pointer, yeah, okay. So cell size equals int dot from bytes database file dot read 1, and then print cell size, and then print database file dot read cell size. That's not helped enormously. Yeah, but these need to be reversed. That's so weird. How it like it reverses the size. That doesn't make any sense. Also, it's only getting 15. But what? Oh my god! What is happening? Oh, I'm being an idiot is what's happening. I need to seek to it. That would help. Pointer. Cell size. Okay. 111. Oh god, we've got some weird formatting stuff going on down here. So, yeah. Oh, it's a var int. Oh, it's a bloody var int. That's why it's. So this one's 0.1. Supposedly. So the point, yeah. No, the pointers are absolute. Which is why I just need to seek to it. So, yeah, this is a var int, which is fantastic. So we need to go up here and again and figure out how var ints work. Variable length integers. So that is looking back at this stuff now. In bytes after this is our row ID, which is our primary key. ID has a value of 0.01 or 0x01. These first two fields are what's called variable length integer encoding. This encoding is used so that we don't use a huge 8-byte field for every integer and waste a bunch of space. Sure. The high bit, so we need the high bit. Oh god. This guy had a function that could pass these things. I think that might be a good idea. Let's do parse var int data bytes returns an integer, and we'll just return 0 for now. And then we can, I guess, bloody hell. So we probably don't want to read all of that. mean, the easy way to do it from here would be to just do a find on that create table string. It would give us an index of the character C, and then we could just skip the length of it and seek until we get to a new line. That seems really shady. Also, what the hell are these things doing? There doesn't seem to be anything here that indicates like the length of a table name. Oh. I'm just at a complete loss at this point. Let's expand up. Let's see what this guy's done. Oh, he's put it in a bloody file. Pars var int. Let's have a look at a different example. Concise. Get meta. There's a lot of people who have done this page header thing. Len, get meta. Oh, this is like. What? Oh, hang on, there's lines here. This guy's done it exactly the same way. This is like exactly the same code example. Everyone must have done what I've done and just gone, I don't know. Oh, there's a few ads. Ads will run shortly for some viewers. Okay, I guess I could take a drink break while that's going on. For those that are still here, you're the lucky ones. Or you're running an ad block system that still works. So I don't know how the ad block system. Well, I don't know how the ad system works on this. Because there's an ads automator which is turned on because I wanted to see what it did, and I don't quite know why it's getting to there, but oh well. Do one. Cool. Well, I think I just learned something about how the ad system works. I'm really not sure. What? How many ads are gonna run? It's just doing it forever now. Hang on. What is going on? Okay, are we back? Is he gonna do it again? No. Okay. That was weird. Yeah, I have no clue. I'm not sure this is realistically going to be something I'm able to figure out on a stream, because the problem is when you're streaming, that's so much mental capacity is actually going into streaming. It's the same problem with videos. That's why I plan everything. Because if I had to do everything on the fly in videos, they'd all just suck. Yeah, I've no idea how this is doing what it's doing. This is pars var int. That's in a different file. Yeah, someone has just literally ripped out someone's full example. I wonder if someone had done it here. I don't think so. Oh, there's mine. It's not marked as concise. There's 2 comments on it? What? Oh, okay, just the bot just has an AI thing, I guess. Okay, interesting. There's some. I don't know how these variants. I don't know. My brain's done for. I think it's over. My brain's like stuff in a million places. Right. Okay. Oh, I just realised there's dark mode up here. Hang on a second. So if we undo this dark mode. There's a dark mode. There's been a dark mode on this page the whole time, bro. Farting.c. Oh, is it a .c file? Is this something in the standard library or something? Import var. Whoops. Import var. No. So yeah. So it's like what? Rn.c. Oh, here we go, yeah. There's Rn.c here. Christ. Yeah, my brain's fried. I think my brain is gone between trying to work this out. Like, file systems are a nightmare to work out anyway. They're not really my area of expertise. I can't even talk anymore. On top of streaming, I think we're done. I can't go on. So yeah, that was CodeCrafters. If you want to die, there you go. If you look at the description, yeah, if you fancy giving this a shot yourself and trying to outdo me, maybe not on a stream where you can actually put all your brain capacity into it, then go nuts. There's plenty of other things you can do as well. You can learn new languages with it. You can, let's see what else they've got. CodeCrafters, if I can actually spell, that would help. So you can build your own HTTP server. You can build your own interpreter. You can build your own shell. Well, this one was free. I didn't actually see this one. Well, this one actually looks as though it's going to be quite... Oh, it's a long one though. Yeah, well, yeah. I wanted to do a short one in the hope that I would be able to I'd maybe stand a chance of getting through it in the stream. And that didn't happen. Build your own grep torrent. If you want a real ball ache, you can build your own Redis, which has 55 stages, which is pretty extraordinary. Yeah, there's a whole host of stuff on it. If you want to go have a look at that. In the meantime, thanks for everyone that showed up. Thanks for everyone that was in the chat. And I might see you again for another stream, perhaps in about a month or so. Again, I'm not committing to any sort of schedule, if that wasn't apparently obvious by the fact that I think it was like 2 months between streams before. Something like that. Don't know what I'm going to do next. If anyone has any ideas, feel free to leave them here or in some comments or in the Discord server or whatever. Yeah, I'll see you around.